Hi, I'm Robin from MGM Security Partners, and today I would like to present you the security risks of the CI/CD pipeline and what the OWASP top 10 CI/CD security risk list can tell us and teach us about how to configure our pipelines in a secure way. So first of all, some words on the MGM group I'm working for. The MGM group is a software development company that is basically creating software for the public sector, industrial, insurance, or e-commerce. Additionally, we have a sub-company that is doing management consulting and another sub-company, the one I'm working for, that is doing security consulting and penetration tests. So basically, the company I'm working for is MGM Security Partners. Originally started with executing penetration tests, but nowadays we offer a broad spectrum of security-related topics for all companies that are creating software or using software. So basically every company. We are doing source code analysis. We can do mobile app security. We fair security workshops. We do trainings. Basically, I do most of the trainings for DevSecOps and software development, secure software development lifecycle. We do consulting for other companies, and we are big in cloud security. Okay, this is enough for a commercial break here. So let's get started to the real topic. And what is the real topic? Let's imagine we have a fake company, Normal Corp. Normal Corp is creating some products for small clinics where they can manage their patients and the patient data. And they are creating software to get an overview over all the patients' data. And they provide this software in the cloud. So basically, this is what Normal Corp could do. A software development company doing or creating software for small clinics, okay? And now let's have a look at the environment of this Normal Corp. So Normal Corp is a more like old-fashioned company. As a CI/CD software, they use Jenkins, pretty old software, but to be honest, most companies nowadays still use Jenkins. And Jenkins is linked to a source code management system. In case of Normal Corp here, it is not linked to one source code management system, but to three of them. In this case, it is Bitbucket, GitHub, and GitLab. And to be linked to it means that the CI/CD software has hooks to the source code management software to recognize when there is a new pull request, when there is a commit, when there is a new tag release, stuff like that. And at least the CI/CD software has the rights to clone every project in the source code management software. So this means that the CI/CD software for this execution for this task needs keys or tokens. So these tokens need to lie, in the case of Normal Corp, directly in the CI/CD software, directly in Jenkins. So let's imagine for Normal Corp, for one project, we check out or clone a specific commit we had. We clone the current state of the Git project for this commit. And then what we do, of course, normal modern software and software projects are not written from scratch, but they are developed using dependencies. So the first thing the CI/CD software is doing when, for example, for a node project, the CI/CD software is executing npm install, then it needs to fetch the dependencies. And for this company in Normal Corp, of course, they do not use public dependencies, but they proxy the dependencies through their own registry or Artifactory. In this case here, Normal Corp uses JFrog Artifactory for all the libs and the Docker containers. So in this case here, it fetches all the dependencies for this project from the local JFrog instance. And for this, it also needs, once again, credentials or tokens to be able to fetch the local resources in the local JFrog instance or JFrog Artifactory instance. And then let's say, okay, it builds the software and then it deploys the software to a testing system. So it does unit tests first, of course, but then when the unit tests are done, it is able to deploy the software on a test environment. And for this, once again, it needs some tokens and rights that enables the CI/CD software or the CI/CD ecosystem and the specific step in the pipeline to deploy the software into the testing environment. And by that, it means that the CI/CD software has access to all the components, but also to the full network. I have this laser pointer here to the full network that is behind this testing environment. So when the testing environment has access to specific servers here that a normal user or normal developer should not have access to, it means that when a normal developer can bring in some specific code here in the CI/CD software by injecting code in the project or injecting code into the build commands, then he or she has access to these instances of computers into this network or on the build system and everything that is lying here. So going on in the example here, so let's assume that all the tests are green, everything works perfectly, then the CI/CD software has the right to get the results, whether the tests were successful or not. And then in the most companies I know, it is the case that also the deployment process to the productive environment is part of the CI/CD or software, or is part of a specific pipeline. And this is also the case for Normal Corp here. So Normal Corp, first of all, sorry, I missed something out here. So first of all, when the tests are green, then of course a specific artifact is packed, a Docker container or something like that, and this is released here to the local JFrog Artifactory or registry, or released to maybe also a public registry. And then when it is released, now the sentence I wanted to say, then in this case here and in many other companies as well, the CI/CD software has the right to deploy the software to the productive environment. And this again means that when some attacker, some advisory can bring in malicious code here in the source code management system or in the build instructions or CI/CD instructions, the advisory is able to get access to these resources here. Yeah, and in this case again, it is a little bit special maybe. The CI/CD software also has some like cron job pipelines that are running on a regular basis that fare some scans and get some status and compliance checks, or the results of status and compliance checks back. So what did we learn so far? We learned so far that the CI/CD environment is a very important step or part of the company ecosystem, and that when an advisory gets access to the CI/CD components, let it be the source code management system or a registry or the CI/CD software or the testing environment, productive environment, they get many rights in our companies, and we do not want advisories to have these rights, of course not. So on the other hand, we had Normal Corp, and on the other hand, there's Evil Corp. Let's imagine Evil Corp is just, seems to be an Eastern European hacker community or group of hackers that want to create the most harm possible for European companies. And in this case here for Normal Corp, because Normal Corp has the management software for small clinics, and the medicine sector or medical sector is always vulnerable. So they try to get data and get into the normal corp infrastructure and normal corp source code here. Okay, so let's see, or let's look together what attacks can be done on normal corp just by using vulnerabilities in the CI/CD configuration. So in the first group of attacks we would like to have a look at are attacks from outside. So attacks where an advisory does not need to be in the company, does not need to have access to the company network. They can just do it out of the internet without having access in the company directly. And the first thing a good hacker would do is, of course, read all the public information that are available about normal corp. And here in this case, as a hacker, we can be very happy because normal corp has a developers block that is publicly readable in the internet. And here they are announcing that they are very happy because they have or they provide a logging library, and this logging library makes it possible for all the developers to just import this normal corp logger library, and all log lines are written to a centralized server, but they do not have to configure anything. They just use this library. Perfect. Okay. So why are we interested in this? We are interested in this because we learn from this here that normal corp has a library that, I have this laser pointer here, that is called normal corp _ logger. So we know, okay, this seems to be the name here of this dependency. And we know it is available in version 2.7. Okay, so going to normal corp. Imagine that there is a node project, and this node project here requires normal corp logger in version 2. I have the laser pointer in version 2.7 ... and point* here means that it uses the latest greatest patch version that it can find. So it can be 2.7.9, but it also can be 2.7.14 if there is some version like that. Okay, so then what happens? I go back to the laser pointer. So the CI/CD system here is doing the build, and for this it fetches the package JSON information, and it tries to execute npm install. And for npm install it realizes, okay, I do not have normal corp _ logger 2.7 anything in my local cache, so I have to fetch the resource from the local JFrog Artifactory. And then the JFrog Artifactory is looking into its cache and knows, I have normal corp _ logger 2.7.3, please take this one. Perfect, everything is clear, everything works. No space for a hacker here, right? So what could a hacker do? Well, what a hacker could do is use dependency confusion and just try to find out whether the company missed to configure the JFrog Artifactory or any other repository system here in a proper way. And how to do this? He just creates in a central repository, so in this case here in the central npm repository, a normal corp _ logger in version 2.7.4. So he has to find it out what a specific version it is then, because the block entry just said it is in 2.7, but no patch version in this case. But let's assume he defined it and tried out 2.7.1, 2.7.2 and so on, and finally got 2.7.4. And now what is happening when the company normal corp did not configure JFrog Artifactory or its repository management system here in a proper way? Then the following is happening. Normal corp logger, or the project is needing normal corp logger in version 2.7. So it means latest greatest. It goes to the CI/CD system here. CI/CD system is executing npm install, and npm install says, okay, fetch it from the local proxy for npm. The local proxy for npm is JFrog Artifactory. JFrog Artifactory says, yes, I have normal core blocker 2.7.3 locally, but then if it is not configured properly, JFrog Artifactory says, yeah, but let me first of all ask the upstream repository whether the upstream repository has a higher version defined. So it goes to npm and asks npm, hey, do you have a higher version? And npm in this case has a higher version, and JFrog will cache this here and deliver this to the build system, and then we can define as an advisory, for example, to just get a specific token that is defined here in the build system and where we have access in this step of npm install, or we can define an installation script of the npm package here. But basically the idea is that we bring in some malicious code that it is giving us some information we should not have access to, or we get access to specific infrastructure or resources we should not have access to. So fetching a specific service that is just reachable out of the internal network here. So you could imagine that. But basically this is the attack, and in the end, if it is executed and the execution here in this specific pipeline step has access to this token, we get this token sent to the server of the attacker, and this is a problem for us. So why is this the case? So it is the case because for every single ecosystem of software, for every specific language, we only can define one specific proxy, or in the most situations we can only define one specific proxy. So in this case here for npm, we can say for the build environment or for the developers notebooks that for npm we do not go to npm directly to the central npm repository, but we go to our local JFrog Artifactory. And when we go to our local JFrog Artifactory, we go to it for only internal packages, but also for central packages like, I don't know, Babel or stuff like that, that we would like to use from outside. And now JFrog Artifactory has to decide, is this a local package or is this a normal central in the internet defined package? And the answer is it cannot know it before we didn't configure it in the right way. And this attack is called dependency chain abuse. It is here, as you can see, on level 3, so to say, or has place 3 in the top 10 list. So the basic idea here is that an attacker can abuse flaws in the way how dependencies are fetched, and engineering workstations or build environments are affected by executing these malicious packages or scripts on their environment directly. Attack vectors are dependency confusion, what we talked about so far, that we just go to the regular repository in the internet and define a higher version and hope that the system is not configured in the right way and tries to fetch a higher version from outside, from the public repository. Another way to do this is dependency hijacking. So dependency hijacking basically means that, for example, an advisory waits till a package that is broadly used by many companies gets free because the person that is maintaining this package has no time left for maintaining it, and then it is defining or creating the package directly again when it is free, and then he or she can bring in malicious code. So this would be a basic idea, or to get a maintainer of a specific project and spend some time to create good code, but then when nobody is watching, or when he or she works for some years for this project, he or she can bring in malicious code then. So this would be dependency hijacking. Then there is the attack vector of typo squatting. Typo squatting means that for a normal computer, characters are completely different because they are binary, and I don't know, a 0 and an O, it does look completely different for the computer because the binary representation of it is completely different. But for us as a human, it looks equal. And one case of typo squatting could be that an advisory defines, for example, a new package called Babel, but instead of using Babel with the small l at the end, he or she uses a big I in the end. And then he or she creates a tutorial with the text, with the requirements directly defined as text, so that persons that are watching this tutorial or reading a blog post about it can directly copy and paste it. And they will not see that it is not Babel with a small l, but Babi with a big E, and just copy and paste it and then take the malicious version instead of the official version. Or another thing would be brand checking. Brand checking means that for specific brands, like let's say Google maybe, or I'm not completely sure what kind of packages they give out, but sometimes specific brands use specific ways of naming their packages, like company name underscore and then something, or at something underscore something like that. And brand checking would mean that you try to define a new package that is named in a way that it could be from this specific brand, but it is not actually. It's just defined by you, and then as an advisory you maybe have some hours before someone is recognizing you as a malicious project, where specific projects or specific victims use this package already. Okay, so these are the attack vectors, and now what could we do? What could be a possible mitigation for that? So first of all, we should always use fixed versions. So instead of 2.7 point star, we should use 2.7 point, and then maybe in this case of time, or in this point of time, it was version 3, the latest greatest. So we should consider to use the explicit version here. And then we could also think about using hash codes instead of using a version. We should or could use a specific state of this package. So when someone is overriding the version, for example, then we don't mind, because they cannot, when they change something in the code, they cannot create the same hash value again. So we would be secure here or safe here on this side. And another thing that I already covered is that we should configure our Artifactory or repository managers in a secure way. And in a secure way means that we define all the patterns that we would like to use in our company to make sure that these packages, Docker containers, whatever, are local only, and we will never fetch them from the internet. Maybe you now ask how to define it. So for JFrog platform, for example, when you use, like in this example here, the Docker Hub proxy, then you can define exclude patterns here. And in our case here for MGM, it means that we have com.mgmtp. and then ** and stuff like that. That is never taken from the outside, from the internet. So when someone goes by and defines a package, or in this case here a Docker image that is called in a specific way that we also use internally, it would mean in this case here that our Artifactory would never fetch this from outside. And by that we would be safe against dependency confusion. Okay, so what are the recommendations? First of all, you should prohibit the download of packages directly from the internet for your build system and also for all your engineering workstations. You should ensure that all the packages are pulled through internal proxies, like in this case here through JFrog or the factory. And this is more an IT thing, but you should enforce that developer computers, developer workstations are shipped with a secure client configuration by default. Or you have, most companies have this, such a development installer where this installer is placing secure configurations for your whole company and for this development workstation then. Then I also talked about it some seconds before, is you should check for checksums or signatures, and you should use exit versions instead of the latest. I have many discussions with persons from the business that are saying, yeah, but I would like to have the latest version and I do not want to adapt the version again and again. What should I do? So the best thing here, in my opinion, is you use an exact version and you create a process how often you would like to check whether you would like to bump the version to a higher one. You could also use tools like VulnerateBot that help you to find out whether there is a new version, and in the best case they can create you a pull request and you can just accept the pull request if your tests are running green and everything works out. And if not, then you already know, okay, maybe they changed something in a way that our interfaces are not working anymore. And then you know, okay, then we have to adapt something deeper, and then also the latest version would break our build directly. So I hope that this is a good advice for this problem here. Then what you should do is to ensure a company-wide naming rule for private dependencies. And this means that you have a wiki page or something where every developer knows, when I create an internal package or Docker container or whatever, when I create one, I have to match this naming rule to be sure that this is not affected by dependency confusion, that no person from outside can just define it and then overwrites my local version of it. Okay. Yeah, then some other parts here, or some two more list items here are to run the installation scripts only in separated contexts. So in contexts where you do not expose any secrets or access to sensitive resources, and that you ensure that your internal projects are shipped with default and secure configurations, so that you be sure that you can override your local config if it is not secure in this way. Okay, so then let's say this was the first attack. Then let's have a look at the second one that could be possible from outside. The second one possible from outside is called here replace a public Python library. So what do I mean with that? Imagine we have a public project here on GitHub, and it is creating a Python library, and we have a build server internally in the company Normal Corp, and this is building this public library here based on GitHub, and then it is publishing this public library here to PyPy, so that every customer, for example, of Normal Corp could use this library. Let's say it is an API wrapper for some products of Normal Corp for this management software, for example. So what could happen? Well, what an advisory could do is, when it is a public library or it is a public project, just try to find out whether there are credentials left in the full Git history, because sometimes we just start with creating a project and then someone is accidentally, of course, committing a secret, and then he or she is just deleting it and committing again, but another version then. And anywhere in the version history, we can maybe find a secret. So what an advisory could do is just use a tool like Git leaks. And in the best case, like in this case here, he or she would find a PyPI token, a PyPI credential or secret here, to have access to PyPI. And in this case here, then it means that he or she can bring in all the malicious code he or she would like to bring into this library that every single customer of Normal Corp is maybe using when it is an API wrapper, for example. Override it, bring in malicious code, and upload it in its own name, or in the name of Normal Corp in this case, because he or she has the credentials to Normal Corp's PyPI user account. And then it would be overwritten and no customer would know about it. This attack is called Insufficient Credential Hygiene. The basic idea behind this attack is that an attacker has the ability to obtain and use secrets, tokens that are in some configuration files or that are left in the Git commit history in any file back in time. And these secrets are spread through the pipeline, and then an advisory can use them to get, for example, access to, like in this case, PyPI, and do insecure stuff, right? So we have to do it again, it's clear. So this risk is called insufficient credential hygiene, and as we can see, it means, or the basic idea behind it is that an attacker has the ability to obtain and use secrets, tokens, as we have seen that there are tokens in the history, for example. And what are the recommendations? What can we do against it? So first of all, we should do what the advisory did here in this case. We should scan the artifacts. And we should scan, of course, also the Git history once when we publish it. And when we have some secrets that we can find in the artifacts and we already published them, then the only thing we can do is to roll the secrets. We cannot use them anymore. If they are public, we have to disable this secret and use new secrets, of course. What we should do additionally to this is that we should think about mapping credentials, where we use credentials in which systems, and of course we should make sure that credentials always follow the rule of least privilege. So when we have a specific credential to, for example, in JFrog Artifactory, to read some resources, some dependencies, then these credentials should only have read permissions to this specific proxy, for example, but it should not have write permission to other projects or to other spaces. You should only use a specific secret for one specific contact, so you should not use this secret in this pipeline, but also in the pipeline of another project. You should have project-specific secrets. Even if they are able to read the same, you should make sure that for a specific project, you'd have one specific secret that is related to this project. You should prefer to use temporary credentials that are destroyed themselves or are not valid for too long time, in the best case not forever. As I already said, you should rotate credentials when they are published anywhere, but you should also periodically rotate them to make sure every year or every some months that you change them to reduce the risk that they are publicly known. And you should limit credential usage to predetermined conditions. So you could think about that a specific credential can only be used when it comes from a specific IP address or when it comes from a specific identity, whatever the system matches here. And of course, you should only grant the pipeline steps the permissions they need. So when you have a testing step and this testing step does not have access to, I don't know, JFrog Artifactory, then don't give it tokens to JFrog Artifactory. Give the tokens really, or the secrets or access to resources specifically only to steps in the pipeline that need this, and better create more steps with smaller sets of permissions than to create one step out of, I don't know, simplicity, and then giving it all credentials. And then when some command in this flow of steps or of execution commands is attacked by an attacker, then you have a problem, because then in every case they have access to the credentials. So only give the credentials to the steps in the pipeline that need access to these. Okay. So what could you do? Of course, what you could do is to include Git leaks in the pipeline directly, or in the best case, as a Git hook before you commit any changes, and then you would know, here's a credential you are trying to leak, so we should not publish it already to PyPy, but in this case it would be part of GitHub. So in the case when we recognize that something, some secret was published, we should make sure that we invalidate it and create a new one. Okay. So, and then we have a third attack where we can say, okay, we can do something from outside without having any access to the company so far, right? We still do not have access to the company so far. And this is called, or the idea behind it is that it is really easy to integrate third-party components into CI/CD pipeline steps nowadays. And one example for this is this fictive, is it called fictive? I don't know. Is Cloud Test IO, what is made up in my mind. I hope that it is not existed. And what Cloud Test in this example here is doing is that it gives you, for example, an overview over all the test cases you executed, and the only thing you have to do is to download in your CI/CD pipeline here a test tool shell script. It is published in a web server. You just download it under a fixed URL, and you download it and always get the latest, greatest version here. And then this test tool is executed next to your really test cases, and then it publishes information about what test cases were running on a cloud infrastructure. So let's imagine that this is the idea behind Cloud Test, right? So let's say normal corp board such software. What could an advisory do in this case, right? What would be a possible attack without having access to any of these systems here, because they are belonging to normal corp? What an advisory could do is to try to attack Cloud Test directly, because when it is a startup, then it maybe is possible that they are using credentials that are getting public, for example, or they are not, that they are affected by a good phishing attack or something like that. So what our advisory could try is to get access to Cloud Test IO, and in this case then maybe they are able to get access to the test tool sh that is running in every single pipeline of every single customer of Cloud Test IO, and in this case here of normal corp. And one thing he or she could bring in then in this test tool sh here is, for example, a curl line that is sending all the secrets, all the environment variables defined so far here, and sending it via or to the web server of the advisory here. And now you may think, yeah, Robin, but this is pretty made up here, right? Who should use such a test tool in its pipeline and downloading it for every execution? It does not seem to be something persons would really do, but persons really did. It happened to CodeCuff. CodeCuff, when I understood it right, was or is maybe even a software to track the code coverage of tests. And it was part of the supply chain, as I explained here. So CodeCuff said, hey, here you can download our shell script and just use the shell script in your build environment, and we give you the coverage data online. And what happened was that attackers gained access to a secret. When I recall it correctly, then the secret was part of a Docker container that was public. So they were able to reveal the secret, and this secret gave them access to the place where this shell script was uploaded for the customers, where the customers downloaded this. And in this case, they were able to just bring in a line, and it is pretty much the line I showed you already. This line is saying, yeah, please give me the git remote so that I know what kind of server it is and all the environment variables. And by this, the attackers were able to get all the environment variables of all the customers that were using this specific testing step here of CodeCuff, and giving this testing step credentials, right? So when they exposed AWS tokens, database usernames, access to some testing environment, stuff like that, all this could be read by the advisory here in this case. So it is a real world attack. I did not make this up. It's a real world attack. So, and what we could sum it up, or under which, I don't know, phrase we could sum it up, is ungoverned usage of third-party components or services. So the idea is that it is pretty easy to use third-party services, and we grant them access to our source code management systems, CI environments, build systems, whatever. And this expands the attack surface to our company infrastructure. So what are the recommendations to don't have this problem? So recommendations are to use only third-party components, software, scripts, whatever, when they are manually approved. Give them least privilege. So in case of this CodeCuff, for example, or the example I made up before, when you execute the script, but the script has no access to secrets, because in the step where this script was executed, no secrets were revealed to the environment variables, then we would be safe. That would be okay. So this would be the idea of limited permissions to the least privilege for this third-party scripts or components. And then more central for the company, we should document the method of integration. We should document what third-party library scripts we are using, and review the configuration and the usage of them from when to then on a periodically basis. Okay. Another thing where we could sum this attack up is the improper artifact integrity validation. So the idea behind this is that an attacker has access to one of the systems in our CI/CD environment and can push malicious code or artifacts or whatever Docker containers down to the pipeline, and there are no mechanisms in place that validate this code or validate the artifact or Docker container or whatever. So recommendations for this is that we should always try to validate our resources or our artifacts or containers that we are using. by using, for example, code signing. You can sign commits and then it's clear who created them. By verifying artifacts we are using, also by using signed artifacts, or at least verify that checksums are the right checksums we would await here, or where we have a manual check before that the specific state of this artifact has a specific hash code, and we pin this hash code, and then we verify this hash code later on, and when it was changed we know, okay, we cannot use it. We could configure a drift detection, and or no, we could use a configuration drift detection and at least check hash codes. I already said this. Okay, so what would be the mitigation for this? The mitigation for this in this case could be the case that Cloud Test.io maybe has a public key infrastructure and would give out a signed version of test tool sh. So this version, it could be that it is signed, and when an advisory would try to change it and you check the signature on the side of your build system, the attacker would not be able to execute malicious code in your CI/CD pipeline, because you check it before, and the advisory here would not be able to create a valid version that is validly signed by the public key infrastructure here. So this could be a solution for this. Okay, enough for attacks from outside. We still have some attacks from inside. I hope you are still on my side, because we are very long already. But I promised the persons that attend the security conference, where I hold a small version of this talk here, to create a fully version of this talk, and this is the fully version of this talk. So when you come by and see this, sorry that it is so long, but this is to cover every single attack here. Okay, so what we have seen so far are the attacks from outside, and now we look at the attacks from inside. So let's imagine Normal Corp has fixed all the attack vectors, all the possible attack vectors from outside, and now they are bringing in maybe some a person that is looking like a person that's searching for an interchip, maybe in the subsidiary in Prague, and they have a person inside in the inside network. Okay, what can happen then? Well, what could happen then is, when you have access to the pipeline, just to steal the secrets in the pipeline. So let's imagine the following. For Normal Corp, we have a project here in GitHub, in Bitbucket, and we have a build system, and the build system is creating a Docker container based on this project here. And then it is publishing or releasing this Docker container to the local JFrog Artifactory, to the Docker repository here in JFrog Artifactory. So to do this, or in order to do this, it has a secret key here that has write permissions to the JFrog Artifactory Docker repository. Okay, so what can we do as an advisory when we can not directly write to the main branch, but we can create pull requests on this, and these pull requests are running at least test code here in the CI/CD pipeline. So we can create a pull request, and this one is at least executing the test steps of it. Well, we could assume that we can then just change the Jenkins file, because in this case here it is Jenkins, and the Jenkins file is part of the project. And we could just assume, okay, how could this token be called? Maybe we already find it in the Jenkins file, and when the Jenkins file is already using the token, we see, here's the step where JFrog token is used. So we copy this over to the test steps here, and additionally then we just send the token here to our advisory controlled server, create the pull request. In the best case, then this pull request is running in the Jenkins server, and we have the credential for the JFrog token, and then we have access to, or write access to, JFrog Docker repository, and can just overwrite the image that we just created here. And the positive thing about this is that it is really hard to detect that we exchanged this, because when we exchange it only some seconds, maybe milliseconds after the pipeline pushed its version, it is hard to detect for when you don't have like an intrusion detection system or CM system that is looking for anomalies, because it looks like the pipeline was finished on, I don't know, 8:20, and 8:21 this one was uploaded again. So the last upload was 8:21, pipeline was finished on 8:20. I guess it matches. So it would be hard to detect if you don't have anomaly detection here in place. Okay, so this is a problem. This is not so good. And what this is called is poisoned pipeline execution, PPE. So the basic idea behind this is that the attacker has access to the source control system, but he or she has no access to the build environment directly. So what the attacker can do is then manipulate the build process by maybe injecting malicious code or commands in the configuration of the build system, and then running this malicious code as part of the build process. And what we have seen so far here is a direct PPE. So direct PPE means that the attacker can manipulate the CI configuration directly in a branch or a fork and execute the code by pushing it or by creating a pull request. In our case here, it was a pull request. So what would be a possible mitigation? A possible mitigation would be to protect the build definition. So in our case here, the Jenkins file. In some source code management systems, like in GitLab, for example, in the ultimate version, it is the case that you could create like logs for specific files, and only specific persons or groups can change these locked files. So you can restrict access to build definitions, for example. Another way, maybe in this case here for Bitbucket, I'm not so familiar with, it could be that you cannot create locks for specific files, but then you should, you can use, for example, two other ways. You can create an own repository for your build definition files, so in this case here for your Jenkins file. Or you could always, in the build system directly, not use the Jenkins file from the current pull request, but always overwrite them with the main branch, for example. So these would be two ways how to protect against this direct PPE attack here. Okay. So then let's assume that we have done this here. We use, or a normal corp is moving this Jenkins file here in an own repository, and the advisory has no access to the repository, but still the attacker can create a pull request on the basic project. Can he or she do anything else to use this then, or to abuse this in this case? And the answer is, well, it depends, but in the most cases, in the most modern software projects, you don't really use the build definition file of the build environment to really define logic, but you use something like Gradle or whatever to define more complex tasks you would like to execute in the build, because in the end, a developer should be able to do the same steps as your environment. And for this reason, or out of this reason, we are using, for example, Gradle. So if this is the case here in this project, then it means, yeah, you cannot overwrite the Jenkins file, but maybe in the Jenkins file it is the case that you have a with credentials environment around a Gradle clean test here. And you get the JFrog token also in the Gradle clean test step. So, and if this is the case, what our advisory could do is then just to define in the build Gradle where he or she can overwrite or bring in new code, just create a new task that is sending this token to his or her server and say the test step that is executed here depends on this step. So it has to be executed before. So then if this is successful, and in this case here we just assume it is, the build system before any test case is running is sending the information, the token in this case, to our advisory controlled server, and we have a problem here. So, and again, of course, as in the direct PPE, we are then able, using this token, to replace the Docker container and having the success here that it is hard to detect that we changed anything. Yeah, okay. So this is called then indirect PPE. The idea behind this is that we cannot directly change the CI configuration because it is protected by another branch or is protected by the source code management system, and we cannot override it. But there is any kind of second file that we can manipulate and that is referenced by the pipeline. So for example, a make file could be here possible, or in this case here, a build Gradle file. Or we have some kind of test system where when the unit tests or something like that are executed, maybe we have a before script or an after script where we, I don't know, create some folders and delete some folders. Maybe we can override the script patterns there and send us the credentials in this case. Or we should not miss out here that we also have linters or maybe scanners defined in the pipeline, and maybe they have some malicious places like a before script code or something like that, where we can bring in commands that are giving us access to the pipeline, and in the worst case then access to credentials, secrets, or resources we should not have access to. Okay, then there's another third category that is called public PPE. It is, I guess it is just to make sure that, or to make clear that this is mostly the case for public repositories, that many public repositories allow the contribution for every person, and to make the work of the maintainers as unannoying as possible. Commonly they run automatically tests, or tests are fetched or created, run automatically. And this means that in the most public repositories, CI pipelines run unreviewed code and in the worst case expose secrets to users just by creating commits or pull requests. Okay. So what could we do? What is a possible mitigation in this part here when we have an indirect PPE? Well, one way would be, of course, to also block access to the build Gradle file. So every single file that is related to the build system could be or should be maybe protected. Not only the Jenkins file, but also the build Gradle, also script configurations or test system configurations or linter configurations. And the second thing we could do is to make sure that for the test step that is executed automatically for pull requests, we make sure that we do not expose any credentials. The credentials then just are exposed for the publish image step, where we really need to publish the image to JFrog Artifactory. But before, for just executing the test, we don't need the credential for JFrog, so we don't give it to it. Okay. Some basic recommendations. What we can do here is to run the pipe, or we should, when we run pipelines with unreviewed code, we should do this in isolated nodes, nodes that do not have any network access to critical environments we have in the company. We should not expose secrets to those steps. We should not expose sensitive resources like any external nodes, or I don't know what stuff we have in our company. For public repositories, we should really consider not running pipelines directly with unreviewed code, or just running some small subsets of tests, but only when a person then really manually runs the test that that is in charge to decide whether this pull request is non-malicious, then starts the real test suite. Maybe this, we could consider this. We should make sure that sensitive pipelines that are given secrets, that are having some access to sensitive resources, are only executed on branches that have branch protection. So branch protection in this case means that only a manual 4i, 6i, whatever review is giving then access for this code to this protected branch, and no code that has no approval by a human being is merged to this branch, to make sure that sensitive information that even developers do not have, like I don't know, an AWS token with write access to some Kubernetes cluster or something like that, is not revealed to persons when they do not have a manual approval here. Always try to or consider to review the CI configuration before the pipeline runs, or override it with a already controlled version of it. As we have seen, move your configuration to a protected branch or protected environment, or directly to the CI/CD system if this is possible, and only give the permissions needed. You already heard it. Okay, so this is so far this attack, first attack from inside, poison pipeline execution. What else can we do? So let's imagine, and this will be top one vulnerability or risk for CI/CD pipelines. Let's imagine we have a project, Bitbucket project, and this Bitbucket project here is for deployment, because we are deploying some Terraform configuration here in an AWS environment. And once in time for normal corp, it was the case that on Saturday, when nobody was working except of one person that had like a night shift, they have or had to deploy the environment on the AWS again. And they defined, of course, that you need a 4i principle. So you need a manual approval. And because it was a problem, because nobody was in front of his computer or her computer, and the one person that was in charge and recognized, oh, our services are not running, we have to redeploy them, could not find another person, they decided afterwards that they allow that you can change the Terraform configuration, but only in a secure way without a manual approval. And only in a secure way, in this case, means then that they implement a checkoff in the pipeline. And when you change the configuration for your pipeline, checkoff is running its checks. And when it is checking in a successful way, then it is deployed. And when you bring in some vulnerability, then it is not deployed. Okay, so this is the basic idea, but for that, you do not need a manual approval. This was the idea of normal corp, because they have the problem that only one person is there at the weekends or having emergency shift and is reachable. So therefore they decided, okay, a specific group of persons can publish Terraform configuration, but it has to go through checkoff, and only if checkoff is saying, yeah, it's okay for me, it is deployed. Sounds like a good idea, right? So what could an advisory and attacker do? Let's assume that this attacker was able to become part of this group, part of the group that have or has write access here to this repository and can change the Terraform configuration, but it needs the checkoff check. So what the advisory cannot do is to override that checkoff check is taking place, because the Jenkins file is protected here. So what could an advisory do? Well, he could try to make the Bitbucket, not Bitbucket, the S3 bucket here in the configuration public, right? So he would try to make it public, publish it, or commit it to the repository and push it. And then the pipeline would run, checkoff would run, and checkoff would decide, no, making it public is not a good idea. So the checkoff check fails here, right? Okay, so he cannot do anything. What a pity. But he could try to just override the checkoff configuration here with this YAML file, with this checkoff YAML, because the checkoff YAML was not defined in this project. So he can just try to create it and override it. And what he can do is to say, yeah, checkoff, you are allowed to fail softly, so to exit with exit code 0, even if there was a problem. And please, as check, execute my check. But the problem is, my check is not defined. So what happens is when he or she adds the checkoff configuration here, is that the checkoff configuration in the pipeline is overwritten, and checkoff says, yeah, okay, I tried to execute my check. There is no my check. I have soft fail true, so I exit with exit code 0, and exit code 0 means success, and success means I have, or the other persons in Evil Corp have access to the S3 bucket. This is a problem, I guess. So what this is top one problem of CI/CD pipelines. It is called insufficient flow control mechanisms. The idea is that an attacker has permissions on one system in the CI/CD process and can push malicious code, configuration in this case, or artifacts or containers or anything down to the pipeline, because no manual approval or review is in place. So what are the recommendations? The recommendations are to implement branch protection, to only release or deploy on protected branches, and to ensure that you need manual review when you would like to merge to any protected branch. Avoid auto-merge rules, like in this case here, that it is built and then directly deployed. So in this case here, auto-deploy rule, just because of some automatic checks, right? And then really good way would to only allow artifacts that are maybe signed or in any way marked or ensured that they come from a secured part of your pipeline or of your process flow, that only these secure artifacts flow through your system, through your pipelines. Okay. What is a possible mitigation? Well, in this case, it is not really a technical mitigation here, but it is logical or a company-wide mitigation. So the mitigation in this case would be that you need the manual approval, and you as a company have to make sure that this manual approval can be also done on Saturdays. So 2 persons at least should be available out of this group that can check over the changes of the other person. Okay, so sometimes we do not have technical solutions for things. Okay, so, and yeah, what other problems or what other risks do we have in CI/CD pipelines when we are in the company, so when we have access? What you could think about is that we have a Jenkins server here, and what these Jenkins servers in the most cases have is that these Jenkins servers do not execute the builds directly, but they have Jenkins agents, or any build system in the end has agents that are executing the real tasks. So what is happening here is we have a Jenkins server. This Jenkins server has some kind of credential or secret, and in this case here, it is the SSH login to the server where the Jenkins agent is running. And when this is the case and we are using one single agent for our Jenkins server, then what could be a possible problem and what could be a possible attack our advisory could do? Right, he could say, yeah, first of all, we could check for a person that maybe has the permission to configure nodes, so to add nodes. So to say nodes in this case means other computers in the network where these Jenkins agents are running. So let's say our advisory here knows that we have a specific person, and this specific person has, I don't know, a deactivated or an old account, not deactivated, of course, an old account. And this account is still there. It is not based on any central user management system because it was created back in time, and it has an insecure password. So we could just try to do a brute force attack, find out the password of this person by using a password list. Normally we do not have any restrictions when we are inside, and we can just again and again use this password list to try to find out using brute force what password is used for this specific user account. And then when we have the permission of this person that has the permission to configure a node, maybe it's an administrator, but maybe has no access to the secret, we could create a new agent, a new Jenkins agent, but instead of setting up an Jenkins agent, we set up an SSH man-in-the-middle server, and this man-in-the-middle server is giving us the credentials that are used for the SSH server, and by this we have access to this build agent here, or to the node where this build agent is on. And this means that we can grab every single code, we can change code, we can grab credentials or files, secret files that are created by other projects that are executed and built on this server. So then it would mean that our advisory that should not have access to any other project has access to this project and can directly change them while they are built, can apply patches, can fetch secrets, everything like that, just because he or she has done SSH access to this server. Okay. What we can sum this up under is inadequate identity and access management. So the idea behind is that we have problems to manage the vast amount of identities over many systems. We have human accounts, technical accounts, and the recommendation on this is to have a continuous analysis of all the identities we have on the systems, force a central identity provider, map the level of permissions that are really used for the system. So when you have a specific account that is administrator because he or she needed it for some configuration, then take away the administration rights after this configuration. Make sure that you write it down that this person is not needing this configuration in a week, and then remove this rights a week after this. So remove permissions when they are not necessary is another point here. Removing stale accounts. In the best case, always create accounts with a date of disposal. So define accounts with an ending date. Forbid the registration to systems with non-domain addresses because you do not have access to them, and disable self-registration in the best way in all cases, and avoid shared accounts. For every single person, every single technical user, create an own account so you can delete these accounts, and it only affects one person or one build system and not the whole team, for example. Okay, And then another thing where we could sum it up is insufficient locking and visibility, because of course it would make a problem here in this case that we use a password list, and when we would have a good locking system that is looking for anomalies, don't mind, then we could create an alarm based on that, because normally it should not be the case that a person is trying 500 passwords in some minutes against a Jenkins account. So normally the persons know their account, or they do not know, then they try 5 passwords, and when the 5th password is not matching, they reach out to the IT and say, can you please reset? So, but that you have a single account that uses 500 times another password should not be the case, and you could create an alarm in, for example, your CM system. Okay. So what could you do? In this case here, it's easy. Just deactivate, as learned a minute before, just deactivate all the accounts you do not need anymore. Okay, then I guess it is the last one. We could still maybe access secrets in other pipelines. Let's imagine you have a project, a Bitbucket project, but as advisory, you do not have access to this Bitbucket project. And you have a Jenkins server, and as we learned so far, some minutes before, the execution is not on the Jenkins server itself in the most cases, but it is on a Jenkins agent, on a node that is running Jenkins agent. And this, in this case here, this project where you have no access to is downloading a private key somewhere in the build steps. And in this case, it is not good configured, of course, but when they download the private key from some server, they save it under temp private key, because they do not know that they're on a shared runner. So what could an advisory do? He or she could create another project, and this project he or she has access to, of course, when he created it. And when this project is running, you could try as an advisory to create pull requests or commits directly in the moment when this pipeline is running. And then you could bring in your Jenkins file something like curl and send this temp private key file. And when you have some luck, then this project here and this build is running on the shared runner, so the same runner, and all the resources that are globally on this runner can be accessed by this advisory here then. And then in the best case, again, this private key, this secret here is sent to the advisory, and we can sum up this as insufficient pipeline-based access control. So the idea behind this is that pipeline execution nodes have access to many resources or systems, and you should make sure that you cannot abuse the permission granted to a pipeline and move laterally within this CI/CD system, or even outside the CI/CD system. So what is the recommendation on that? You should not use shared nodes. You should ensure that secrets are scoped, that secrets are only in the scope of this execution, that you reset your runners after the execution of your build or test or whatever you did. And by not using shared nodes, you also could, for example, use instead Docker containers and then delete the Docker containers after the runs again. You should only run pipeline jobs with limited permissions on the node, so that they cannot create anything out of the scope of the node that is deleted after the execution. You should ensure, of course, that the nodes are patched regularly. Ensure that the network is segmented. So network is segmented in this case means we always discuss about you are stealing some secret as an advisory, but it could also mean that you try to get access to some internal server, some server that only the build system has access to, because it is in some network segment where this access is granted. So in this case, then you should make sure that your build system and your runners do only have access to the segments of the network where they need to have access to, but not to the other segments, like to the development workstations, because sometimes development workstations have insecure ports open because they have a testing environment running or something like that. Okay. So what could we do? Of course, we should not use shared runners. So what we could do is to create an own runner here for every single project, and then this project here would have been run on an own runner, and in this case, then we would not have access to the private key. Okay. The last attack, as far as I recall here, is to hijack outdated infrastructure. So let's imagine you have a Jenkins server in a very old version. I'm not completely sure whether this version is vulnerable, but let's just assume you have a Jenkins server and a node with a very old Linux system, for example. Then what could an advisory do? Well, you can just run, for example, Metasploit on the server, get access to it, and this would be a problem. And this is, when I'm not completely wrong, the last risk we have, insecure system configuration. So it means, or the idea is that you have insecure configured or unpatched systems in the pipeline, and these are low-hanging fruits for attackers. So what you should do is continuously check for vulnerabilities and update your infrastructure, limit network access, and review your configuration. And you could also set up in infrastructure as code automation for your configuration to make sure that your configuration was not changed and that it is always matching secure best practice. So what we do, for example, is to do updates about Ansible scripts or a wire Ansible script, and make always sure that we have a secure configuration of all our servers. Okay. So once again, what we learned so far, we had these 10 CI/CD security risks. We covered all of them. Sorry that it is such a long talk. With some examples. So what you should have now is a very good overview, or at least a broad overview of all the possible risks you could be faced with in a CI/CD pipeline, what could happen. Of course, not every attack is applicable for every single build ecosystem. In some ecosystems, most of the attacks are not possible, but you have an overview now what could possibly go wrong. And when you work for a specific company and you see that a specific misconfiguration or a misunderstanding of how to use a pipeline is in place, you know what to do. Okay, special thanks to the OWASP to coming up with this list, and especially here to the boys and girls of cybersecurity that curated this list and brought up the idea to create such a list. And they were aboard, as far as I'm informed, by Palo Alto. So in this case, I'm not completely sure whether cybersecurity is still a company. So then special thanks to Palo Alto in this case, I guess. Okay, so my conclusion would be, you have seen that CI/CD systems have many secrets and access to resources that is important to our company, what we are working for, and we should make sure that we have in mind that CI/CD pipelines and ecosystems could be an attack surface in our companies, and we should make sure that we always have a secure usage and a secure configuration, and make sure that we have a culture of failure tolerant usage of the systems to make sure our companies are secure in this way. You know many possible attack surfaces now, and you should make sure that these attack surfaces are reduced or smaller, is this a word? I'm not sure, completely sure, that are reduced attack surfaces in your company regarding CI/CD pipelines. Okay, for the reading and playing, of course, the top CI/CD security risk has a script where it is published in, or a paper. You can find it under this link. And additionally, once again, thanks to the boys and girls of cybersecurity, or in this case now Palo Alto, there's a thing that is called CI/CD Code, an setup environment where you just have to run a Docker Compose script and you get everything you need to check out and play with most of the 10 vulnerabilities, where you have examples for every vulnerability. Some vulnerabilities I had in the talk, or maybe even most of them, are out of this CI/CD code. So please make sure you give it a try and hack with it. It makes great fun, or a lot of fun. So, okay, then if you would like to get in touch with me, you can see here my email address. Just reach out to us, to MGM Security Partners, if you need some advice in regard of DevSecOps, in regard of a secure CI/CD configuration. And then thank you for watching this very long video, and goodbye.